Okay, hello everyone. In this lecture series, we are going to discuss approximation methods. In quantum mechanics, approximation methods or tools are used to find approximate solution of multiple particles or for a complex potentials when exact solutions to the Schrodinger equation are unattainable or without solving the Schrodinger equation. Approximation methods or tools are used to solve a complex problem in quantum mechanics without using or without solving the Schrodinger equation. This is the beauty of the approximation methods. These methods provide ways to find approximate solution, not exact solution, approximate solution, or estimate the energy eigenvalues, that also approximate energy eigenvalues. The most common approximation techniques are variational method, perturbation theory, and WKB approximation method. These topics are belongs to MSc syllabus, MSc Physics syllabus for all the universities. All the universities. Okay. Here in this slide, it is differentiate the three approximation methods, the three common approximation methods: variational method, WKB approximation method, and perturbation theory. Here, variational method used to find ground state energy mostly. This method used to find the ground state energy. That means variational method has the power to estimate the ground state energy of a system easily and most accurately. WKB approximation method is a classical semi-classical method which apply for the systems in which potential varies slowly. What is the slowly varying potential, that we are going to discuss when we are going to discuss the WKB approximation method. Okay. Here, slowly varying potential means, suppose I am going to consider this is along y-axis potential is there Vx, along this is your along x-axis. So with distance it is varying, the potential varying slowly like this. So WKB approximation method strictly applied for slowly varying potential. So what is the exact physical significance about potential which is very slowly, that we are going to discuss at that time when we are going to discuss specially WKB approximation method. But in case of variational method, this method apply for any potential. This is not restricted for slowly varying, but it is restricted to slowly varying. Okay. It is useful to find eigenvalues of different states, but here variational method specially used to find the ground state energy, but variational method also used to find the some excited states energy value, first and second excited state uh, energy value also. But variational method is very much essential or useful for determine the ground state energy. Okay. Okay. So here, if I am going to consider the examples in which way it will be applicable variational method and WKB to find the ground state. GS, here I written ground state of linear harmonic oscillator. Accurately it will give find the ground state energy hydrogen atom, finding the ground state energy of helium atom, and etc. If we are going to consider WKB approximation method, it is used to finding the eigenvalues of any state of linear harmonic oscillator, finding transmission coefficient, alpha decay, Gauss theory of alpha decay. In Gauss theory, WKB approximation method, if I'm going to use, then the derivation will be reduced. So for alpha decay, WKB approximation method can be applied, finding transmission coefficient for a potential barrier. This is the potential barrier, and some energy flux came. What is the transmission coefficient T, that can be evaluated with the help of WKB approximation method. Perturbation theory is somewhat different as compared with the variational and WKB approximation method. This method used to find the approximate solution to the systems where a small perturbation is added, means there is some disturbance will be added. Suppose this is a simple hydrogen atom. if I want to find out the ground state energy of the hydrogen atom, then I can use variational method or WKB method itself. But if this hydrogen atom is perturbed by any means, suppose I applied one a particular intensity of a magnetic field, then this ground state energy will be somewhat tailored, will be changed. At that time, we have to use the perturbation theory. So same thing, when the perturbed is added, perturbed means some external disturbance will be applied on the system. At that time, we are going to use perturbation theory. This perturbation theory again classified into time independent and time dependent. Okay, so here I am not going to discuss in detail about. At that time, when we are going to discuss specially perturbation theory, at that time we are going to discuss. Okay, by this method, first order and higher order corrections to energy and wave function can be calculated, where it can be used hydrogen atom. It can be used for hydrogen atom with external field, what I explained over here. When we are going to apply either magnetic field or electric field on a hydrogen atom or any system, then how its energy value will be changed, that can be estimated using perturbation theory. It is used to solve complex systems like molecules, where the electron repulsion term can be treated as perturbation. It is used to compute energy shifts due to the spin orbit interaction in hydrogen atoms. Okay. Other approximation methods are central field approximation method. It is specially used for multi-electron atoms, where each electron is assumed to move in an average potential created by the nucleus and other electrons. And another one, Born approximation method, it is specially applied for scattering theory, where the total eigenfunction solution is replaced by an outgoing plane wave with a specific wave vector. So these are the approximation method we have in our physics. Most common is your variational method, WKB approximation method, and perturbation theory approximation method. Okay, so first we are going to discuss in detail about variational method, then we are going to go for WKB, then we are going to go for perturbation theory. Variational method. The variational method, here in short I written VM. VM approximation method or tool is used to find ground state energy of a system if Hamiltonian of that system is known. Hamiltonian, that is your H, total energy operator. If we know, then we can estimate the ground state energy. The ground state energy will be evaluated by using trial wave function. One trial wave function we are going to construct, or maybe in question it will be given that we have to use to find the ground state energy. VM approximation method also used to find the energy of excited states by considering trial wave function. What I told in our previous slide, it is also useful to find the excited state. Whenever I am going to solve some problem at that time, you can clear about that, how the excited state values can be evaluated using a VM approximation method. Okay, so this is all about your introduction to different approximation methods. Okay, in our next class, we are going to discuss in detail. We are going to start to discuss in detail about variational principle or variational method, which can be proved by a theorem. So this theorem states that the average value of Hamiltonian of a system, which is written as like this: psi, this is bracket vector, in between that Hamiltonian is there, and denominator is your psi star psi. Okay, and this is your, or it can be written in the integral format like this: integration all the space psi star h cap psi d tau, and here a mistakenly written h cap, it should be removed. Psi star psi d tau greater than, always greater than, equal to EGS. Here EGS is nothing but eigenvalue of ground state energy, eigenvalue of ground state. So in short it is written as EGS. So if we are going to calculate the expectation value of a system, expectation value of Hamiltonian of a system for a particular state, if I am going to consider psi, then it will be always greater than equal to ground state eigenvalue, greater than equal to, some books it is written approximately to ground state energy value. Okay, so you can write in this way or you can write this way, integration format, or by using Dirac notation or bracket notation. Right, in our next class we are going to prove this theorem, then we are going to move to solve different numerical upon variational method. Okay, so thank you so much for watching this video. Thank you.